Okay, let's continue with problem 11. So in this one, we have some unknown function satisfying an equation. So f of a plus b minus 2 times f of a plus f of a minus b all equals to 2 times f of b minus 1. This is for all integers, a and b. We also know that f of 1 equals 2, and the question is find f of minus 1 plus f of 0. Alright, so this is a kind of typical kind of question. We have to figure out clever values for a and b to plug into this equation so that we can use the given information and maybe generate something over here. So some typical things I might want to try. Let's let a equal b equal 0, see what happens. And in this case, we'll have f of 0 is minus 2 times f of 0 plus f of 0 equals 2 times f of negative 1. Okay, that doesn't help me out a lot, but looking at it, because I don't know if 0 or f of negative 1, but looking at it, if I let a equal negative 1 and b equals 0, I'm going to get f of negative 1 minus 2 f of negative 1 plus f of negative 1. So on the left-hand side, I'm going to get 0. And on the right-hand side, I'm going to get 2 times f of negative 1. So we have a second value for the equation. F of negative 1 is also 0. I already knew that from the previous line. Sorry to baffle that a little bit. Okay, so we know that f of negative 1 is 0, so all we need to know is f of 0. So let's see what happens if we put b equals to 1 and a equals to 0. So if a equals 0 and b equals 1, I'm going to have f of 1, which is 2, minus 2 times f of 0. Plus f of minus 1, which is 0, equals 2 times f of 0. So we have an equation we can solve for f of 0. It looks like f of 0 equals 1/2. So we know f of negative 1 is 0, f of 0 is 1/2, so the answer should be 1/2. And that's answer A. Problem 12, we have two similar solids. The volume of the larger one, so V1 is 16 square root 2 times V2, and we have the sum of the surface areas is 216 square inches, so S1 plus S2 is 216. What is the surface area of the smaller solid? Okay, so you have to know that the ratio the length ratio cubed is going to give you the volume ratio, and the length ratio squared is going to give you the surface area ratio. So using this fact, we know that V1 over V2 is 16 root 2. 16 root 2, well, this is 2 to the 4th, this is 2 to the 1/2, so 2 to the 9/2 total. So 2 to the 9/2 equals, I'll just call the length ratio as R cubed. So R is going to be 2 to the 3/2. So then the ratio of surface areas is going to be 8. Okay, so in the end, S1 is 8 times S2, so we're going to have 9 times S2 equals 216. So this tells me that S2, 216 divided by 9 is 24, yeah? Surface area of the smaller solid, that's what we're looking for, 24 square inches. So that's answer B. All right, problem 13. For what value A does a given equation have infinite number of solutions? So the equation is an absolute value equation. Absolute value x plus a plus absolute value x plus 2 equals 5. I want to rewrite this equation to put the absolute values on opposite sides. So I'll write it as this way. Okay, now what I'm going to do is say the left-hand side is y1, the right-hand side is y2. And what I'm going to see is that the right-hand side is a kind of downwards V with a vertex at 5, negative 2, negative 2, 5. Intercept at 3 and minus 7. And the right-hand side is just going to be a V shape with a vertex on the x-axis, and we can see that if it's either this one or that one, we're going to have. Oh, hold on a second. If it's either one of these two, we'll have infinitely many solutions. Either the range from -7 to -2, or the range from -2 to 3. So A could equal 7 or -3. So there should be 2 answers, and indeed, -3 or 7. C. C is the answer. This would be a good question for my first Algebra 2 honors test coming up just a couple weeks before Mmpc. Problem 14, there's a snail at the bottom of a well which is 115 foot deep. On day 1, it climbs up the side, then at night it slips down. So it climbs up 3 feet, and then it slips down 1 foot. So it goes up 2 feet per day. But once it reaches 112 feet, then it will climb out of the well. The next 3 feet will bring it to the top of the well. So I guess this is going to be 56 days, and then on the 57th day, he's going to climb out of the well. So the answer is B, 57. Two asteroids in space are hurtling directly towards each other. Initially, there's 2012 kilometers apart. Asteroid A travels at 1720 kilometers per hour, and asteroid B travels at 1280 kilometers per hour. How many kilometers apart are they 1 minute before they crash? All right, so 1780 in one direction, 1720 is the speed of one of them, and 1280 is the speed of the other. It doesn't really matter how far apart they start. Essentially, we can say that they're moving together at a rate of 3,000 per hour. So 1 minute, well, I didn't even have to do that. So this is how many kilometers they move in 1 hour. In 1 minute, they move 1/60th of that. I didn't even have to add these numbers because answer A is the same value. Okay. So that's the next 5.